We're going to work out the odds on the quarter 2 final practice. On that blue worksheet we'll have the solutions to every odd problem. The first one, number 1, is a subtraction problem, and first I would distribute the negative right here to each term. So you're going to subtract everything in this second group. So I'm going to take the negative to the 7p cubed and make it a negative. I'm going to take the negative to the 4, make it a negative 4, and the p is already negative, so that's going to turn into a positive. Now you just add them up, and if we go with the highest exponent, that's going to be your p cubes. So you got a negative 1p cubed and a negative 7p cubed, so your total is negative 8p cubed, and those are gone. Then we're going to go next to the p's. So I got a p and a p, so that's plus 2p, and then a minus 1 and a minus 4 is going to be a minus 5. Next one, w to the negative 4/5. First of all, you cannot have a negative exponent, so to fix that we're just going to move it to the bottom of the fraction. So if you write it as a fraction right now, it's on top of a fraction. So we're going to move it to the bottom, and on top is just going to be 1. So w to the 4/5 in the denominator under 1. Okay, now there is a rule that says it's unacceptable to have in the denominator, you cannot have an exponent that's a fraction. So I want to get rid of that w to the 4/5. I want to have w to some exponent that's a whole number and not a rational number. So what can you times it by that's going to get rid of that fraction in the exponent? So you're going to times it by 1, because if you times it by 1, it's not going to change the value. Now you got to be creative and come up with a fancy 1. So here's what I want. At the end of the day, I want this. I want on the bottom, I want w, let's shoot for just w to the power of 1, w to the 1. So when you multiply exponents, and when you multiply powers that have the same base, you just add the exponents. So 4/5 add what is going to give you 1? And my answer is 1/5. So I'm going to multiply both the top and the bottom by w to the 1/5. Alright, if I multiply my top, 1 times w to the 1/5 is just w to the 1/5. On bottom, w to the 4/5, you add your exponents, plus 1/5 equals w to the 5/5, and that is just w to the 1. So I've cleverly come up with a way to get rid of my exponent. Now the numerator, the whole time, is just going to be w to the 1/5. W to the 1/5, and you're done. That is your answer. Alright, a similar problem. X to the 2/3 divided by x to the 1/6. If you are dividing powers with the same base, what you do is you subtract your exponents. So I'm going to take 2/3 subtract 1/6. Now you cannot add or subtract fractions unless you've got a common denominator, and I'm going to change them both into 1/6. So 2/3 is going to be the same as 4/6, and I don't need to change the second. So 4/6 subtract 1/6 is going to be x to the 3/6, or just x to the 1/2. And if they just want you to simplify it, you're done. But if they want you to write this as a radical, then you would write it x to the 1/2. That's the same thing as square root of x. Exponent, the numerator goes right here, and the denominator is your index. So these are the same thing. Next one. Okay, now your instructions do say to change it as a radical. So the one before that just wanted you to simplify. 5x to the negative 3 halves. Okay, it's in parentheses, so this negative 3 halves is going to both the 5 and to the x. So maybe move number 1, let's get rid of this negative exponent. You can't have a negative exponent. So similar to the one we just did, 1 over 5x to the 3 halves. Okay, now let's see if we can let's go ahead and convert it into a radical. So on top is going to be 1. The bottom, if I write my radical, in the radical I'm going to have 5x. Let's put that in parentheses. And the 3 is going to be the exponent here. And the 2 is the index. Alright. Looks like this one's going to be a couple more moves. So we're on move number 3. Move number 3. Simplify this square root of 5x cubed. I noticed that my exponent 3 is higher than my index of 2. So I know that some of these 5x's are going to make their way out. So you just ask yourself, how many times does 2 go into 3? And that'll tell you how many 5x's make it out. So I know there's 1, 2, and 3. So that means a 5x is going to make his way out. And a 5x is still left in there. So there's move number 3. Square root of 5x cubed is actually equal to 5x times the square root of 5x. Okay, now that looks like a pretty good answer, except for there is a rule that says you cannot have in the denominator a radical. So you cannot have the square root of 5x. So it's similar to one we've done. We're going to times it by 1, a creative 1. And to get rid of this radical 5x, I'm going to times by square root of 5x on the bottom and on the top. Okay, on the top, 1 times the square root of 5x, that is just square root of 5x. On the bottom, square root of 5x times the square root of 5x is just going to be 5x times this guy right here, 5x. So I'm going to have 5x times 5x. So now let me write it up here. So your answer is going to be square root of 5x on top, and in the denominator you're going to have 5 times 5 is 25 x squared, and that is your final answer. So it looks like it's a 4 or 5 step problem. Alright, long division. We're going to divide this polynomial with 4 terms divided by a binomial. So let's go v minus 1. Let's go old-fashioned long division. V cubed plus 9v squared minus 17v minus 2. Okay, I start by right here. Just look at this v. And I'm going to do v cubed divided by v. So what can I times v by that's going to give you an answer of v cubed? And your number, or the term you're looking for, is v squared. So now I'm going to multiply v squared by v, and that's going to be v cubed. And you got to times v squared to a negative 1. So it's negative 1v squared. Now you're going to subtract them. So I'm going to subtract this guy, and since I'm already subtracting it, I'm going to add it. So you just change the signs. V cubed minus v cubed, that's 0. And 9v squared plus v squared is 10v squared. Bring down my next term, my minus 17v, and then you just repeat the process. So 10v squared. What can I times v by that's going to give you 10v squared? And the answer is 10v. So 10v times v is 10v squared, and 10v times a minus 1 is a minus 10v. Change the signs, make that negative, make that positive. That's a 0, and this is a negative 7v. Bring down your next term, minus 2. What can I times v by to get a negative 7v? And you're looking for a negative 7. So negative 7 times v is a negative 7v. Negative 7 times a negative 1 is a positive 7. Okay, change the signs, make that a plus and make that a minus, so those cancel, and this is minus 9, and there's nothing left to bring down, so this is the remainder. So your answer is v squared plus 10v minus 7 minus 9 over this v minus 1. So your answer is right here. Number 5. Okay, your instructions say factor each completely. So v squared minus 10v plus 21. Now, if the number in front of your v squared is 1, then it's pretty slick. It's not too bad. What can you times and get for an answer of v squared? So you're just going to take this addition problem and you're going to rewrite it as a multiplication problem. So this right here is your answer. You got to come up with what kind of a problem gives you this answer. So to multiply and get v squared, I'm going to go v and v. And then my last term, my 21, comes when I multiply these two guys right here. So 21, my options are either 1 times 21 or 3 times 7. So to figure out which pair to choose, you have to look at the middle term, minus 10v, and which of these two guys is going to add and give you minus 10. And it's got to be this, and the 3 has got to be negative and the 7's got to be negative, because a negative times a negative is a positive, but a negative 3 and a negative 7 is a negative 10. So my answer is v minus 3, v minus 7. And the order doesn't matter. And number 7. Alright. 2k cubed plus 15k squared plus 18k. First of all, kind of always train yourself to see if there's a GCF. You have 3 terms, so you have a trinomial. Do these have anything in common? And the answer is they each have a k. So if I start off right off the bat and divide each term by a k, or if I factor out a k, you're going to have this. You're going to have k times the quantity 2k squared plus 15k plus 18. Alright, now step number 2. I am going to take what's in the parentheses and I'm going to see if I can factor this. So 2k squared plus 15k plus 18. What I'm going to do is I'm going to bring down this 2k squared. I'm going to rewrite the 15k as 2 terms, and then I'm going to bring down my 18. So I'm going to change this trinomial, because there's 3 terms, I'm going to change it into a polynomial with 4 terms. So what 2 numbers are going to add or subtract and give you 15? Alright, to do that, you are going to multiply the 2 times the 18. So 2 times 18 is going to give you 36. Now let's make a list of the factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Okay, you got 5 pairs to choose from. Which pair is going to add and give you the middle, the 15? And your answer is 3 and 12. Alright, so 3 times 12 is going to give you a 36, but 3 plus 12 is going to give you 15. So I'm going to rewrite this 15k. I'm going to rewrite it as 12k plus 3k. And now what I've done is I've come up with a polynomial of 4 terms, and I can use my grouping strategy to tackle this. So to group them, instead of looking at one problem, let's look at it as 2 separate groups. So my first group is going to be this. Is going to be the 2k squared plus 12k, and I know the GCF of those 2 terms is 2k. So if I divide each by 2k, it's going to be rewritten as a multiplication problem and look like this: 2k times k plus 6. Alright, now my second group, I'm going to group these guys right here, the 3k plus 18. So 3k plus 18, the GCF of those two is 3. divide each term by 3, and you're going to get 3 times k plus 6. Okay, now look at what you've got. You've got two terms. You've got one term here and one term here. And what do they have in common? What is now the GCF? It's the k plus 6. So if you divide each of these by k plus 6, you can rewrite this as a multiplication problem, and it's going to look k plus 6 times, okay, these cancel and leave you 2k, and these cancel and leave you with plus 3. And then the very first thing we did was this k. We divided them all by k. So let's put that k out here in the front, and we'll call it good. That is your answer.